PU2 champions, welcome to day 7 of 21 days challenge to get 95% in your second PUC board exams. So as part of today's challenge, I have given you two chapters for revision: alcohols, phenols and ethers from chemistry and magnetism and matter from physics. So you need to revise these two chapters and practice its most important questions from the PDF I have provided. If you haven't downloaded yet, the link is there in the description section. Please click on the link, visit the page and download the most important questions PDF. Okay, this is very important. And in this video, I am going to discuss the most important questions from the chapter alcohols, phenols and ethers. Okay, these questions are sourced from your model question paper, question bank, and then previous year questions, passing package, and so many other important resources, right? Okay, so now before moving ahead, so I want to just tell you, to help you to be in track with this 21 days challenge, I have prepared a study tracker for all of you. The link of the study tracker is there in the description section. And my dear children, you have to create a copy of this study tracker. Okay, please do not try to edit this one. I'm receiving a lot of edit access. It hasn't to be done like that. You have to go to file and create a copy. And if you're using it in phone, please make sure that you download the Google Sheet app for convenience. Okay, now let's understand the blueprint of this particular chapter. So it's very simple. Here we have 10 marks question, 10 marks from alcohols, phenols and ethers. You get one 5-marker question, one 2-marker question, so total 7, and then you get one 3-marker question. Okay, sorry, you get 3 1-marker question. So 5, 6, 7 plus 3, 10. Now talking about this mentorship session, so a lot of students are facing now a lot of difficulties in their preparation. So many are confused, panicked, stressed, and that is quite natural at this point of time. So to help you, to guide you in your preparation, I have started this mentorship session. The link is there in the description section to book it. You can book and we can have a one-on-one discussion about all your problems, and I will give you all the, I can say, details, all the help, all the guidance that I can do at my best. Okay, so now let's go to the first question. We'll be discussing 2-marker questions, and listen here, the 5-marker questions that is there, it is usually in the form of 3 plus 2, right? So I'll be discussing 2-marker and 3-marker questions separately, and the examiner can just give 2-marker questions and they can mix 3 plus 2 and give you 5-marker question. So in that way, all our questions will be prepared thoroughly. So what are vinyl alcohols? Given examples. So vinyl alcohols are alcohols in which the OH group is directly attached to the vinylic carbon, means the carbon-carbon which is having the double bond. Example is like CH2, CH and OH. This is your vinyl alcohol. Next, what are allylic alcohols? Given example. So allylic alcohols are alcohols in which the OH group is attached to a carbon atom adjacent to a CC double bond. For example, you have a group like this and you have next carbon, and here you have a OH group. Example here is like this. This is your allylic alcohol. Next, what are benzylic alcohols? And give one example. So those benzylic alcohols are the alcohols in which the OH group is attached to a carbon atom directly connected to a benzene ring. Okay, so if you see, I have a structure like this, C6H5, and then I have CH2, and then you have OH, right? So this OH group, this carbon, right, OH group is attached to the carbon which is attached to the benzene ring. Next is what are symmetrical ethers? Given example. So in ethers, you know, R, O, R is there. If both the R groups are same, then we call it as a symmetrical ethers. In which both alkyl groups are the same, they are called as symmetrical ethers. Example is dimethyl ether. Next, what are unsymmetrical ethers? Given example. So ethers in which both alkyl groups are different are called as asymmetrical ethers. You can see one side methyl, one side ethyl. Then it is methyl, ethyl, ether. It is an asymmetrical ether. Identify the major product formed in the following reaction and write its IUPAC name. So you have here propene and H2O and H plus. Now you have to remember that this actually adds water, H plus and OH minus, following Markovnikov's rule. If you have watched my one-shot video, I have discussed that in detail in that video. So here, since this is the carbon with less number of hydrogen, the OH will attach here and the product will be this one, and its IUPAC name is propane 2OL. Next, explain the preparation of alcohol from aldehyde by catalytic hydrogenation with suitable example. So, if you take aldehyde and reduce it with hydrogen platinum, then we will get an alcohol. So, you can see aldehydes on catalytic hydrogenation in presence of nickel or platinum or palladium gives primary alcohols. So, if you have CH3 CHO with hydrogen, you can take palladium or platinum or any other nickel, then you will get CH3 CH2 OH. Next is name the class of alcohols formed when ketones react with sodium borohydride. Okay, so ketones, when you reduce them, you get secondary alcohols, and write the chemical equation. So we get secondary alcohols. You can take an example. So I have taken here propanol, and if you treat it with NaBH4, you will get propane 2OH. Next is identify A and B in the following reaction. CH3COH gives you C2H5 OH. In presence of H plus you get A. Okay, then this A gives with the catalytic hydrogenation gives you B plus C2H5OH. Okay, so this A is actually here. So first of all, you can see here I have an acid and I have an ester. So what will happen? They both will react to give you one ester. So acid and alcohol will react to give you ester. So what is A here? A is definitely ethyl ethanoid. You can see 2 carbon here and 2 carbon here. So this ester which is formed is ethyl ethanoid. After that, what happens? This particular ethyl ethanoid again undergoes catalytic hydrogenation and gives back you B and like what I'll say, this is an ester, right? This is now an ester like this, CH3, CH2, OCO, CH3. Okay, now this ester undergoes catalytic hydrogenation, and now what will happen? It will break to I can write hydrogen with nickel or platinum or palladium. Now this get reduced to give back you both two alcohols. Okay, so one will be C2H5OH with 2 carbons, the other one will also be ethanol. Next, question number 10, give the structure and IUPAC name of the products expected from catalytic reduction of butanol, reaction of propanol with methyl magnesium bromide followed by hydrolysis. So if you have catalytic reduction of butanol, then it will give you butanol, right? So butanol will be converted to butane 1ON. Then reaction of propanol with methyl magnesium bromide followed by hydrolysis. So if you have propanol, CH3, CO, CH3, and you are reacting it with methyl magnesium bromide, CH3, MgBr. Now what will happen? This one will react with this one will react with this one. You will get CH3COH, then you have again CH3 and you again have CH3. Okay, so what you will get, 2-methyl propane 2OL, that is your product here. Next, how is phenol prepared from chlorobenzene, and write the chemical equation. So when phenol is treated with, when chlorobenzene is treated with NaOH at a very high temperature and pressure, like 623 Kelvin and 320 atm pressure, phenol is obtained. And you can see here, first chlorine is treated with NaOH, then first you get I can say a sodium salt of phenol, and then it is acidified to give you finally the phenol product. Next, explain the preparation of phenol from benzene sulfonic acid and write the chemical equation. So benzene is sulfonated with oleum, and benzene sulfonic acid so formed is converted to sodium phenoxide on heating with molten sodium hydroxide, and then acidification of the sodium salt gives phenol. So you don't have to worry that much. You can first directly write that, see, benzene is sulfonated with oleum and benzene sulfonic acid is formed, right? This first product, this one. I'll take a different color. Yeah, this is benzene sulfonic product is formed. Now, so formed is converted to sodium phenoxide on heating with molten sodium hydroxide. Acidification of the sodium salt gives you phenol. So, or you can just write down benzene sulfonic acid is treated with sodium hydroxide in acidic medium to give you phenol. If you know this reaction, you can write it in your own words as well. Next is how tert butyl alcohol reacts with aluminium. Give the chemical reaction. So here alcohols reacts with metal to give you salt plus hydrogen gas. So you know aluminium valency is 3, so it reacts with 3 molecules of the alcohol. Next, how but2ene1OL reacts with PCC, and give the chemical reaction. So if you see, this is a primary alcohol, and with PCC it gives you aldehyde. So it's like this, but2en1OL, when it reacts with PCC you will get a CH3CH, double bond CH and CHO. This first carbon gets converted to CHO. Next, explain Cole's reaction with an example. So here in Cole's reaction, the phenoxide ion reacts with CO2 to give 2-hydroxybenzoic acid. So first of all, phenol gets converted to ONA. Then with carbon dioxide and H plus, it gets converted to OH and COOH. So it is 2-hydroxybenzoic acid. Next, explain Riemann-Tiemann reaction with an example. So on treating phenol with chloroform in the presence of sodium hydroxide, a CHO group is introduced at the ortho position of the benzene ring. This reaction is known as Riemann-Tiemann reaction. So you have OH here, and when you treat it with chloroform and aqueous NaOH, you get a compound like this, O minus Na plus and CHCl2. And after that, again, if you treat it with NaOH, it gets, the Cl gets converted to OH and OH. Then on one carbon, 2 OH group is not stable, so it undergoes dehydration to give you CHO. And after that, with acidic medium, you get salicylic aldehyde. Next, Williams ether synthesis. In this method, haloalkanes reacts with alkoxide ions to give you ethers. You can write down here primary haloalkanes. Okay, that is very important. So you can see you have an alkoxide, it reacts with a primary haloalkane to give you finally a ether. Next, how does phenol react with concentrated nitric acid? Give equation. So phenol reacts with concentrated nitric acid to give picric acid. You can see all the three positions, ortho, 2 ortho and 1 para, are occupied with the nitro group. Next, name the product formed when phenol is treated with acidified Na2Cr2O7. Write the equation. So the product formed is benzoquinone, and you can see OH with Na2Cr2O7 and H2SO4 gets converted to benzoquinone. Next, among alcohols and phenols, which is more acidic and why? So generally what happens in alcohols, the H is released, then you have RO minus, okay, and this RO minus is not stabilized. But in phenol, if you see, once the H is released, okay, you get a structure like this O minus, and now this O minus is resonance stabilized, right? So that is why phenols are more acidic, because phenoxide ion is stabilized by resonance, whereas alkoxide ion is not. Next, what happens when phenol is heated with zinc dust? Write the equation. So phenol on heating with zinc dust gives you benzene. You can see this reaction. Next, what is Lucas reagent and which class of alcohols does not produce turbidity at room temperature? So Lucas reagent is the solution of anhydrous zinc chloride in concentrated HCl, and which does not produce turbidity, that is primary alcohol. Tertiary alcohols produce turbidity immediately, whereas secondary alcohols produce turbidity in 5 minutes. Next, how is phenol manufactured from cumene process? This is very important question. In the past few years, it has been asked repeatedly. So cumene is oxidized in the presence of air to cumene hyperperoxide and hydroperoxide, sorry, which is converted to phenol and acetone by treating it with dilute acid. Okay, so you can see, first of all, you have this particular structure, and then you have OOH, this is cumene hydroperoxide. After that, when you treat it with acidic medium, you get acetone plus phenol. Next is, we'll see model question paper 2-marker questions. What is Lucas reagent? We have already discussed. Which class of turbidity, which class of alcohol does produce turbidity immediately with it? So just now we saw a question which was asking that which class does not produce. Here it is, which class produces. So the answer to the second part is tertiary alcohol. Okay, so this is slightly error here. This is tertiary alcohol. Okay, produces turbidity immediately. Next, compound has a molecular formula of C4H10O. Considering the reactions given below, identify the compound A and write its IUPAC name. So if you see here that HI and heating, that means you are breaking, this is, I can say, cleavage of ether. C4H10O is there. I can have two possible structures as an ether. If you see, you have one structure like this, CH2, CH2, CH3. Okay, one here, one this side, or you can have CH3, CH2 and O, CH2, CH3. This is the symmetrical ether, that are two structures possible. Now you can see that, suppose this is A. Okay, it on gives you C and D. So what will be C and D? It will be two, one will be iodide, one will be alcohol. So CH3, CH2, OH will be one, and the other one will be CH3, CH2, I, right? Now the question is saying that D undergoes concentrated H2SO4 at 413 Kelvin. So if you see, D means it has to be an alcohol, and it gives you A back. Okay, so if D, what was A here? See, suppose this is my A. Okay, so if you take this particular ether, then whatever you will get, you will not get A back there. So if you're getting A back, that means it must be a symmetrical ether, and this has to be D and this has to be C. So identify compound A. So compound A is a symmetrical ether, CH3, CH2, O, CH2, CH3. Okay, and write, I consider they identify the compound A and write its IUPAC name. So it is diethyl ether. Okay, next is question number 3, model question paper 3, question number 23. Write the products formed when anisole reacts with ethanol chloride in the presence of anhydrous LCl3 catalyst. So if you see, you have taken OCH3 and you treat it with CH3COCl, then you treat OCH3, you will get one product here and one product here. It is 2-methoxyacetophenone and 4-methoxyacetophenone. Next, we'll talk about 3-marker questions. Write the mechanism involved in the acid catalyzed hydration of propene. So if you have taken propene and you are reacting it with water molecule, so you will get a structure like this. Okay, so what will happen? This bond will react with this one, and there is a carbocation formed here. Next, nucleophilic attack. So whatever water molecule is formed, that will attack again on the carbocation. So if initial step, what happens? First of all, water gets protonated to give you H3O plus. Okay. Now this alkene behaves as a nucleophile, and the double bond from here reacts on this H and it takes the H. And on the other side, one carbon is a carbocation is formed. Now on this, the water molecule which is formed here attacks on this carbocation, and you get a structure like this. After that, what happens? Deprotonation takes place to form an alcohol. So again, the outside another water molecule will abstract this hydrogen, and then you get a structure like this. Next is write the mechanism of dehydration of alcohols to alkenes. So you have this O plus H2, this is formed here first of all, and then there is deprotonation of water, so you get a carbocation here, and then you have this double bond here and you get ethene plus H plus. Next, write the mechanism of dehydration of alcohols to ether. So here we have O plus, and then it gets protonated to give you this particular water molecule. Then another alcohol molecule reacts with this carbon, and then water molecule is released and we get a structure like this. Here there is a protonated alcohol is still remaining, and then this H plus goes out and you get a structure like this. Okay, write the mechanism of dehydration of alcohols to ether. Okay, I think this is the same question. Next, what is the effect of electron withdrawing group on acidity of phenol? So if electron withdrawing group is there, acidity will increase. If you have electron donating group, acidity will decrease. Increase in the number of carbon atoms. If the number of carbon atoms increases, the boiling mass increases, van der Waals force increases, and boiling point increases. Give details of two commercially important alcohols and what is denaturation of alcohols. So two commercially produced alcohols are ethanol and methanol, and you should remember that methanol is called as wood spirit. Okay, and what is denaturation of alcohol? So addition of poisonous substances to make alcohol unfit for drinking is called as denaturation. Okay, next, how do you prepare aspirin from salicylic acid? And write the equation and the IUPAC name. Okay, so if you see how we can prepare, if you take acetylation of salicylic acid gives you aspirin. So if you take salicylic acid and treat it with an anhydride group, so what will happen? This particular, I can say, OH group gets acylated, okay, and OCOCH3 is formed, and after that this is the aspirin. Acetyl salicylic acid is formed, and CH3COOH is the acid byproduct formed here. Next, we'll discuss model question papers, questions in the 5-marker section. Write the 3 steps involved in the acid catalyzed dehydration. This we have discussed. Ethanol to ethoxyethane at 413 Kelvin, right? So you have to be very careful whether it is asking for dehydration of alcohols to alkenes or dehydration of alcohols to ethers. Okay, these two are very important. Next, explain Cole's reaction with equation. This is also a question we have discussed. Next is how is salicylic acid prepared from phenol, and write with an equation. This is again your Cole's reaction, so it is very, very important. Next, alcohols are comparatively more soluble in water than hydrocarbons of comparable molecular mass. Give reason. So why alcohols are more soluble? Because of their ability to form hydrogen bond. Okay. Next is model question paper 3. Question is there. Write all the 3 steps involved in the acid catalyzed dehydration of ethanol to ethene. So this is a question very, very important. Next, you can see in the second model paper, there was no mechanism asked. Okay, in the first and third model question papers, mechanisms were asked. Okay, salicylic acid preparation, so that is not a mechanism. Next, if you see here already mechanism, 3 steps, 3 marks you will get. I'll tell you the answer of these 2 questions. So if you treat it with Na2Cr2O7, we have already discussed, it will give you an oxidized product which is benzoquinone. Okay, next, if you take phenol with bromine, okay, and if you take phenol with bromine, then you will get here OH, Br, Br and Br. Okay, this is 2,4,6 tribromophenol. 2,4,6 tribromophenol. Okay, so children, these are the most important questions from alcohol. So if I tell you certain name reactions you have to prepare thoroughly, like Riemer-Tiemann, Cole's reaction, that aspirin reaction, and 3 mechanisms we have in this chapter: dehydration of alcohols to alkenes, dehydration of alcohols to ethers, and the hydrogenation of alkenes to give you alcohols. Okay, so these are the reactions that you need to prepare, the mechanisms you need to prepare. After that, these all questions are enough. So thank you so much, and stay tuned for the next video where we will be discussing the MCQs of this chapter. Okay, and let me know in the comment section, are you able to complete the challenge or not? And if you're facing any difficulties, the mentorship session is there for all of you. You can take the use of that as well if you need any help. And all the best, my dear children. Don't panic, just put 100% of your efforts at this point, at this last I can say last phase of your exam. Just give your best. Okay, all the best, and keep learning, keep working hard, and just don't worry, I'm there to help you in every possible